Weather forecasts didn't start with satellites. They started with one desperate need: survival and planning. Before computers, radar, and apps, people still predicted storms, and the system they built was surprisingly modern. Stay with me, because this isn't really about clouds. It's about networks, data, and control. For most of history, forecasting was local. People watched the sky, the wind, and the sea. Farmers used patterns. Sailors used experience. Communities used rules passed down for generations. Sometimes it worked, often it failed. And when it failed, it could destroy harvests, ships, and lives. The big problem was scale. Weather doesn't respect borders, and local signs don't see far away. A storm can form hundreds of miles away, then it arrives overnight. A cold front can sweep across regions like a wall, and you won't see it from one town. So the question became simple: how do you see weather before it reaches you? Here's the twist: you can't predict weather without sharing information. One place can't see everything. One town can't see the whole sky. One port can't see the whole ocean. So the secret system behind forecasting was a network, observers sending standardized reports on schedule. And once that network exists, weather becomes a map problem, not a guessing problem. The first ingredient was measurement. You can't build a forecasting system on vibes. So scientists built instruments: barometers for pressure, thermometers for temperature, anemometers for wind. These tools made weather quantifiable, and once weather becomes numbers, it becomes comparable across distance. But instruments alone don't create forecasts. You need many instruments in many locations at the same time. A single barometer tells you almost nothing beyond your street. A network of barometers reveals movement. So the real invention wasn't just the barometer, it was synchronized observation. Same time, same readings across a region. That's how patterns appear. Now we hit the breakthrough: the telegraph. The telegraph made fast reporting possible. Observers could send data in minutes, not days. And once data moves faster than weather, forecasting becomes possible. That's the key. Before the telegraph, storm reports arrived after the storm. It was history, not warning. After the telegraph, a coastal station could report falling pressure. An inland city could prepare in advance. That flipped forecasting from superstition to system. It became early warning, not storytelling. So how did the system work? It became a daily ritual. Observers measured pressure, temperature, wind, and clouds at fixed times. Then they sent readings to a central office. That office stitched the data into a map. These were the first weather maps. They weren't pretty, but they were powerful. A weather map shows patterns, not just points. It shows where pressure is falling and winds are shifting. It shows where fronts might move. It turns scattered facts into a moving picture. Once you see patterns, you can make a forecast. Not perfect, but useful. And useful is what saves lives. Now here's what made this modern: standardization. If one station measures at 9 a.m. and another at 2 p.m., the map lies. If one station reports in different units, the map becomes noise. So forecasting systems created standards: same time, same units, same codes. Yes, codes. Weather reports were often condensed into coded messages. Telegraph lines charged by length. Short messages were cheaper and faster. So observers used code books. That made reporting consistent and efficient. Standardization wasn't a detail, it was the system. Now, why did governments care so much? Because weather affects power. Storms destroy trade, sink ships, ruin crops, and weaken armies. A state that predicts weather protects its economy, it protects its people, and its military. So forecasting became national infrastructure. It became a strategic advantage. Meteorological offices formed, observation networks expanded. This wasn't just science, it was administration, logistics, and risk management. And it created a new kind of authority, the authority of prediction. If you can warn early, you can govern better. But early forecasts had limits. They were built on patterns, experience, and imperfect data. Without radar, you can't see storms forming in real time. Without satellites, you can't see the full oceans. So early forecasters leaned on pressure systems. Pressure maps were the backbone. Pressure was the best clue they had, and it was surprisingly powerful. Here's why pressure matters. Air moves from high pressure to low pressure. That movement creates wind, and wind drives weather. Wind moves moisture. It shapes storms and creates fronts. So, if you track pressure changes, you can anticipate movement. You can predict likely conditions. Now add shipping. Shipping was a major driver of weather services. Ports needed warnings. Insurance companies needed data. Trade needed predictability. So forecasting often started on coasts. The sea punishes ignorance. Then the network pushed inland because storms don't stop at shorelines. Then railways pushed forecasting even further. Railways run on schedules, and weather breaks schedules. Floods, snow, storms, and heat can cripple routes. So modern infrastructure demanded modern forecasting. The more society depends on systems, the more it depends on prediction. And prediction becomes a public utility. Now, consider the human element. Forecasters weren't just reading numbers. They were interpreting systems. They compared maps over time. They built intuition on top of data. That's why forecasting was science and art. Data gave structure, experience gave judgment, and judgment mattered because lives depended on timing. Over time, the math improved. Scientists began modeling the atmosphere with equations. They treated weather as physics, not mystery. That was the birth of numerical forecasting. But early computation was slow. Calculations took time, and weather doesn't wait. So forecasting became a race against time. You must collect data fast. You must process it fast. You must publish warnings fast. The entire system is about speed, because a forecast delivered late is not a forecast. It's trivia. It's yesterday's weather dressed up as insight. That's why communications mattered as much as science. Now here's the big reveal. Forecasting before satellites was a communications network. Sensors spread across geography, standardized reporting, and centralized mapping. Then rapid distribution of warnings. It was an information supply chain. Collect, standardize, map, interpret, warn, over and over. And that information supply chain shaped the modern world. It reduced maritime disasters and improved agriculture planning. It made transportation more reliable. It made the future feel measurable. It also changed how people thought about nature, not fully controllable, but partially predictable. That shift is huge. It changes behavior at scale. Then, satellites arrived, and everything expanded. Satellites didn't invent forecasting, they gave it eyes. They filled blind spots over oceans and remote regions. They made global coverage possible. They made models more accurate. They made warnings earlier. But the core system stayed the same. Collect data, standardize it, map it, model it, warn people. So next time you check the forecast on your phone, remember what you're really seeing. You're seeing the end result of an old network, a system built from telegraphs, instruments, maps, and standards. Forecasting isn't magic, it's infrastructure. And it started long before